Hey everyone, today's video is all about 10 AI diffusion models that we need to keep an eye on and stay updated with in 2024. In our previous video, we showcased the incredible and stunning demo of Google Lumiere that allow for the creation of highly realistic and top-quality AI-generated videos. Now, let's dive into something new that I'm excited to share with you. The first one on our list is called Act Anywhere. This project is a collaboration between Stanford University and Adobe Research, and they're working together to develop these innovative models. We can expect them to be released sometime this year. What's fascinating about Act Anywhere is its focus on subject segmentation and the use of custom backgrounds for subject movement. Essentially, this model allows you to merge a video source with a custom background seamlessly. Take a look at the example on the screen. The water elements you see in the background are not part of the original video source. They're actually added during the segmentation process. This capability to combine different video sources with custom backgrounds opens up a world of creative possibilities. Moreover, the integration of subject movements with the backgrounds is truly remarkable. In the abstract, the creators highlight the importance of generating background visuals tailored specifically for the movements of foreground subjects. This is a significant challenge faced by the movie industry and visual effects communities. As I mentioned earlier, the movie industry often relies on elaborate setups with green backdrops to achieve CG animated effects in their films, particularly in genres like sci-fi. However, I recently experimented with a similar concept using my own workflow, where I could stay in one position while the background objects moved dynamically. And guess what? I stumbled upon a research paper that explores this very idea. It's truly inspiring to see that there are researchers and developers who are actively addressing these challenges and coming up with unique AI models to tackle them head-on. Their approach is quite similar to the workflow I experimented with. First, they take the input videos and apply segmentation to remove the backgrounds, leaving only the foreground subjects. They then denoise the segmented subjects using various techniques as they need to build models that can handle this task efficiently. They use a VAE encoder and merge it with the backgrounds, employing a clip image encoder similar to Stable Diffusion's. This allows them to understand the content of the loaded images. By combining these features and designing an architecture, they generate an output that seamlessly combines the foreground subjects with the background image. If this diffusion model is released, it would be an incredibly practical tool for industries such as movie production and design, as well as motion graphics professionals. Now let's move on to the next model called World Dreamer. This model is a collaborative effort involving various contributors and has its own GitHub page. Although the code hasn't been released yet, they do have demos and introductory materials available. The latest news update was on January 18th, indicating that the initialization of the model has begun. The method employed by World Dreamer primarily focuses on tokenizing images and videos and then combining them into a mask. This is the first approach they tackle. Additionally, they utilize an LLM encoder. As you may know, I recently started another AI-focused channel where I discuss the advancements in large language models. This is because I firmly believe that AI in image and video processing is an ever-evolving field that continuously demands new innovations. In the future, we can expect to see the integration of diffusion models with large language models working together as a unified system. It won't be a matter of simply pasting a script generated by a chat-based language model into a diffusion model. Instead, these models will be combined into a cohesive framework. I believe this is the right direction for researchers to explore. They are working on various applications such as text to videos and image to videos, similar to stable video diffusions. Additionally, they specialize in video stylization, allowing you to change the style of subjects or characters within the videos. It's an exciting model to follow on their GitHub, even though they are still in the early stages as of January. Let's wait and hope they will release something soon. Moving on to the next model, we have custom videos, which focuses on using text to videos. This model allows you to merge two or more subjects into a single generated video. For example, you can input keywords like President Trump and sunglasses along with toy bear and bike, and it will produce a video of a bear riding a bike. The model is trained specifically for combining two subjects into a single scene in the generated videos. From their method, we can see diagrams illustrating the process. They use segmentors to align and sample the two subjects, merging them together. The output result is influenced by the text prompts, allowing you to specify the actions or interactions between the two subjects in the video. However, it's worth noting that if the AI models are not trained to handle multiple segments, the generated results may lack clear identification of the subjects. For example, in the Dreamproof and Video Dreamer examples, the models struggle to properly identify and combine the two objects, resulting in ambiguous or distorted outputs. Indeed, the custom diffusion model demonstrates impressive capabilities by merging two bodies into one, creating intriguing visual effects. It's a fascinating concept and a noteworthy advancement. Having the ability to include multiple subjects in text prompts is a significant development. It allows for more precise control over the generated video results, even down to details like different colors for a character's outfit. It's worth mentioning that existing models, including stable diffusions, can sometimes struggle to identify and incorporate multiple colors or subjects into the generated output. So, the focus on improving this aspect in the diffusion models is commendable. Moving on, the next model is called Unit VG, developed by Baidu, a prominent tech giant in China. Baidu's venture into the AI industry, particularly in the realm of multimedia and large language models, is a significant step forward. Their examples showcase realistic video generation and even explore fantasy styles like sci-fi. However, it appears that Baidu's model still faces challenges when it comes to generating human characters, especially in close-up shots. The quality of facial features, such as the face and eyes, seems to be lacking compared to their performance with animals and objects. It would be beneficial for them to invest in training their AI models, similar to Stable Diffusions, to improve the generation of human character faces. By doing so, they can achieve better results in this aspect. The next model is VideoCrafter 2, which is the second version of VideoCrafter. While I haven't personally used the first version, it's interesting to see the side-by-side comparison between the old and new versions. It would be worthwhile to explore the latest features and advancements in VideoCrafter and assess its potential for video generation tasks. It's great to see that VideoCrafter 2 has made significant improvements in terms of detail, motion, and object alignment compared to the previous version. While there isn't much information available on their research page, their GitHub page provides more insights. They have already released their image-to-videos model called Dynamic Crafter, which you can explore further. On their GitHub page, you'll find a comparison of VideoCrafter 2 with Stable Video Diffusions in a YouTube video. It's worth checking out later to see the differences. The showcased videos demonstrate the capabilities of VideoCrafter 2, and it appears to generate more consistent and coherent results compared to Stable Video Diffusions, especially when it comes to objects' movements. For example, the legs in the generated videos remain clear and visible throughout the duration. The cinematic styles showcased in the videos also look impressive. However, it's important to note that most of the demos provided are relatively simple examples of source of videos or images being transformed into better AI-generated videos. To fully assess the model's capabilities, it would be interesting to test it with more complex images and see how well it performs. It seems that VideoCrafter has already released models for text-to-videos, image-to-videos, and even Hugging Face models. They provide installation instructions for running the models on your local machines. The settings they mention, such as the dimension of 512, resemble those used in Stable Diffusions 1.5, indicating that they may have built upon the principles of Stable Diffusions. If you're interested in trying out the demo, you can download and test it yourself. VideoCrafter appears to be a promising model to keep an eye on, particularly for its text-to-videos and image-to-videos capabilities. Moonshot is an intriguing project focused on video generation and editing with multimodal conditions. It aims to transform subjects from one image into different backgrounds or themes, such as a car, a robot, or a bear astronaut. The model primarily emphasizes image-to-video transformations using diffusions and text generation. Similar to other video generators like Picalabs and Runway, Moonshot includes text-to-video functionality, which is considered a fundamental feature in diffusions models. It allows users to provide simple natural language text prompts to generate videos accordingly. The model also incorporates ControlNet, which likely enhances the control and manipulation of generated videos. Although Moonshot's website lacks detailed diagrams or technical explanations, they showcase comparison results between their model and Stable Video Diffusions. In the initial half-second, the results may appear similar, but Moonshot's enhancements become apparent as the video progresses. For example, they achieve more dynamic movements of the robot's hands and legs, distinguishing their model from many existing video generators that primarily rely on static camera panning. While Moonshot's GitHub page is currently in its early stages and lacks substantial content, it provides an introduction to their project, along with relevant papers and theoretical discussions about their technologies. It would be worthwhile to follow their progress and see if they release their models for further exploration and testing in the future, particularly considering their multimodal approach that combines different diffusions models to create animated video models. Videos Drifter is a project that combines a large language model with diffusion models to streamline the process of creating video scenes based on scripts. It offers a time-saving solution for video production, particularly for faceless YouTube channels or anyone who wants to convert scripts into video format. The framework of Videos Drifter involves using scene descriptions such as Scene 1, Scene 2, and so on, which are input into a large language model. The model understands the instructions and generates the corresponding video output. The scenes are stacked in sequence, and if there are multiple scenes, they are combined to form the entire video. This approach addresses some of the limitations and inconsistencies that can arise when using ChatGPT or similar models. Instead of manually copying and pasting scene scripts into platforms like Picolabs or Runway, Videos Drifter provides a more cohesive solution. It ensures that the characters in the generated videos are consistent in style, which helps viewers easily identify and connect with specific characters. One of the common issues with AI video generators is the lack of consistent styles, even when using text prompts. Videos Drifter aims to solve this problem by ensuring that the generated characters maintain a consistent style throughout the video. This improvement can be beneficial for faceless YouTube channels and other users who rely on AI video generation methods. Overall, Videos Drifter offers a promising solution for generating videos based on scripted scenes. By integrating a large language model with diffusion models, it provides a more efficient and consistent approach to video production, saving time and improving the overall quality of the generated videos. Instruct Videos is a project that focuses on instructing video diffusion models with human feedback. While the initial demos may not appear particularly special, a closer examination of their results at different steps, e.g. 5K, 10K, and 20K, reveals increasing clarity and finer details in the subjects, such as the example of a dog. It would be worth monitoring this project to see if they make their models available to the public, whether as open source or through their own video service. Exploring their progress in the coming year could be worthwhile. Moving on, Biggerpool is a model developed collaboratively by Microsoft, the University of Washington, and Microsoft Research. Its primary focus is on mass diffusion for video results. The model employs line graphs to direct object motions, allowing users to specify paths from point A to point B or multiple points within a single motion scene. The method involves the use of a temporal attention module and is demonstrated with examples like moving eagles. This practical tool offers precise control over object motions in AI-generated videos, going beyond simple camera panning movements commonly found in many existing AI video generators. It's worth keeping an eye on this project to see if they have made any releases or updates on their GitHub page. Lastly, the photorealistic model is another notable diffusion model, particularly for videos. Although specific samples are not mentioned, the results are described as being close to Google's Lumiere models in terms of realism and consistency. The objects generated by this AI video model exhibit a high degree of realism, creating an immersive viewing experience. This model could be of interest to those seeking photorealistic video generation. The photorealistic capabilities of the model you mentioned, particularly in generating detailed and realistic scenes, including examples like an astronaut reading a horse in slow motion, are impressive. The ability to define their desired motions, whether slow or fast, and generate exciting videos using prompts adds to the model's appeal. The emphasis on movement and the potential for more dynamic character animations sets this model apart from existing AI video generators. It seems like a valuable tool for those seeking realistic and engaging video generation. If this model is released, it could offer great benefits to content creators and video producers. It's always exciting to explore new developments in AI and see how they can inspire and enhance various creative endeavors. We look forward to future updates and the possibility of being an early adopter of these models. Have a fantastic day and take care. Goodbye.